In this video, we're going to discuss the different types of chemical reactions. So chemical reactions can generally be classified in one of 5 different classes of chemical reactions. The first type is a combination reaction. The second is decomposition reaction. Then we have single replacement reactions, double replacement reactions, and finally combustion reactions. So let's take a look at each of these types and analyze the general format for each reaction so that you could recognize it when you see one of those reactions. So let's start with a combination reaction. Combination reaction follows this general format. Combination reactions are also called synthesis reactions. And in this combination reaction, you generally have 2 or more different reactants, and they combine chemically to form a single product. So 2 or more reactants reacting to form only one product. Let's take a look at a few examples of combination reactions. Here we'll look at 3 of these. And pause the video and look at them carefully. You'll see that in each of these reactions we start with 2 different reactants. You could have more, but generally 2 reactants, and they combine chemically to form a single product. So all of these would fall into the combination reaction format. The next class or type of reaction is called a decomposition reaction, and it follows this general format. In a decomposition reaction, you have a single reactant that decomposes or breaks apart chemically to form 2 or more simpler products. So we start with one reactant and it breaks down chemically to form 2 or more different products. So let's look at a few examples of decomposition reactions. Here are 3 of them. And in each of these reactions, we start with a single reactant, as you can see, and then it undergoes some chemical process, maybe it's heated up or something, and it decomposes to form 2, or in this last case, 3 different products. Our third type of chemical reaction is a single replacement reaction. And these follow this format that you can see here. Single replacement reactions are sometimes called single displacement reactions. And they occur when you have a single element reacts with an ionic compound. So Bc would represent an ionic compound where B is the cation, C would be our anion. And essentially this single element switches places with one of the ions. So you can see here A plus Bc, the A and the B switch places, and we form AC plus B. Let's look at a few examples to help illustrate single replacement reactions. Here are 3 reactions, and again, take some time and look at each of these carefully and convince yourself that they do follow this format here. Here we have calcium plus hydrochloric acid. The calcium switches places with the hydrogen, and we end up with calcium chloride plus hydrogen gas. In this one, my bromine switches place with the iodide ion, and we end up with sodium bromide plus iodine. Again, each of these equations is balanced. And here, potassium reacts with water. We get potassium hydroxide, so the potassium switches place with hydrogen. We get potassium hydroxide and hydrogen gas. Now let's look at the next class, which is a double replacement reaction. You can see the general format here. A double replacement reaction is also called a double displacement reaction. And these can be recognized because we have 2 ionic compounds. We have AB, so A is my cation, B is the anion. Here C is the anion and C is the cation, D is the anion for our second ionic compound. And the ions in the 2 compounds change partners or switch places. So the cation of one compound combines with the anion of another. So look here carefully what happens. My cation A switches places with the cation C. So AB plus CD, A combines with D and C combines with B. We always write the cation first in any ionic compound. So take a minute and study that format. Let's look at a few examples to help illustrate double replacement reactions. Here we have 3 of them, and in each of these, notice that essentially our cations switch places. The iron here is paired up with sulfide, but my iron and the hydrogen cations switch places. So we end up with iron chloride and hydrogen sulfide. Here we have sodium chloride plus silver nitrate. The sodium and the silver switch places, and we end up with silver chloride and sodium nitrate. And you can see here in the last one, the same thing happens. When we write our products, again, we always have to pair them up based on charges. Iron is a +2, chloride is a -1. That's why we have 2 chlorides. So you might want to review your naming compounds rules, your naming ionic compounds rules, to help you remember how to write your products correctly. And finally, we have a combustion reaction. You can see the general format here. And combustion reaction occurs when oxygen, O2, molecular oxygen, reacts with a hydrocarbon in order to produce water and carbon dioxide. A hydrocarbon is a compound that contains carbon and hydrogen. Sometimes it may also contain oxygen, but here we have CXHY. Could be any ratio of carbon and hydrogen. This is just a generic formula. But we always react our hydrocarbon with molecular oxygen, and we always have the same 2 products, carbon dioxide and water. So let's look at 3 examples of combustion reactions. You can see in all of these we have some hydrocarbon, and that hydrocarbon is reacting with oxygen to produce carbon dioxide and water. Again, we have different coefficients in order to balance these, but overall these are all good examples of combustion reactions. So here's just a few tips to help you recognize these 5 types when you see them. Does the reaction contain oxygen, carbon dioxide, and water? If so, it's likely a combustion reaction. Do simpler molecules form one more complicated product? If yes, then we have a synthesis or combination reaction. Does a single reactant break apart into 2 or more simpler products? Well, that's a hallmark of a decomposition reaction. Is there an ionic compound and a single element on the reactant and product side? Then it's likely a single replacement. And finally, are all the compounds ionic compounds on the reactant and product side? If so, that's a hallmark of a double replacement reaction. Let's practice a few. Take a look at these balanced chemical equations and try to classify them as one of the 5 types of reactions that we discussed. Pause the video and give it a try. Okay, so the first one, we can see we've got carbon dioxide and water as a product, so that's a combustion reaction. Here we have 2 reactants combining to form one product, that's a combination. Here we have a single product decomposing into 2 products, single reactant decomposing into 2 products, that's a decomposition. Here we have a single replacement, my aluminum is switching places with the copper. And finally, here we have 2 ionic compounds that are switching partners to produce 2 new ionic compounds, and that's a double replacement. Let's try one more set of problems here. For these, predict what type of reaction this is, and then see if you can predict the products and balance the equation. Give it your best shot, pause the video, and see what you come up with. Okay, so let's take a look at these. The first one, we've got 2 compounds that are essentially ionic compounds, and so this will follow the double replacement formula. So my barium and my hydrogen switch places. I end up with barium sulfate and hydrochloric acid. We haven't balanced these yet. We'll come back and balance them in a minute. Here we have a combustion reaction. We have a hydrocarbon and oxygen, so we know carbon dioxide and water must be the product. You can see here we have a single replacement, so my copper and zinc are going to switch places, give me zinc sulfate and copper. And here we have a combination reaction, cesium and bromide combine. Cesium forms a +1 ion, bromide is a -1, and so again these will be combined at a 1-to-1 ratio. This one's a little trickier. We have carbonic acid. We have 1 reactant. So this is a hallmark of decomposition. They're a little harder to predict the products, but essentially this one would be water and carbon dioxide. Then we have to balance them, so we can put in our coefficients, only our coefficients. So we should have answers like these. So check your answers against mine and be sure that you can recognize and classify a particular chemical reaction, and be sure if you're given the reactants that you can predict what type of reaction it is and also be able to predict the products.